the next sword I'm doing is the Soul Reaver from the Legacy of Kain Blood Omen series. I've actually done joke tutorials about this sword before. Back in the day, I resisted doing these long form videos for the longest time because I didn't think they'd be useful to anyone. It's like, unless you have a welder and a grinder and a plasma cutter and stuff, not a lot of what I, you know, there's not a lot of mass appeal to these, but you know, now I realise a lot of you guys don't actually care about, you know, doing the sword yourselves. You just get a kick out of watching me build them. So this is the first time I'm doing a real tutorial for this thing. So the basis of the, where's it gone? This part, the handle, is a pair of hemispheres. On previous ones I've done, these hemispheres in here have been mild steel, and when I was ordering these stainless steel ones, I was slightly worried that because stainless steel is generally used for more genteel applications, this wall would be thinner. But it turns out, as luck would have it, that the stainless steel ones are an even heavier gauge. So that means I'll be able to do welding and grinding without worrying. Before, when I met the stainless steel one, or the regular steel ones, I'd always be careful to you know, cut out or whatever and weld. Like this part with the horns will be a big base plate, so that the hemispheres themselves weren't actually load bearing. But these are thick enough that, like, you know, it wouldn't actually matter that much if they were load bearing. These two guys are still going to be welded to a base plate, which will have the horns and stuff. So I often get emails from you guys, young lunatics, asking where I get my steel. It's not very mysterious at all. You can just order it. What would you call this place? Like, how would you describe this type of... I like tell them a welder supply place or just a steel supply place. What would you...
So we're Mid-City Steel. We're a steel service center. Whether you're building giant swords or giant buildings, we'd be your one-stop shop for steel. In addition, we carry all sorts of welding supplies. Yeah, we're a one-stop shop. Anything made out of metal is what you want to come see.
But the steel component, if you had a young lunatic going to Google, what would they, like, what kind of words would they use?
We're pretty well on Google. If you Google anything steel-related, Massachusetts, we're probably going to pop up.
Okay, so yeah, and then this is what these guys, I give them a rough dimension, they cut out a blank, and then I do the rest. It's not difficult at all.
Anybody can do it.
The black Sharpie line I actually prefer, but the chalk line is easier to see under the plasma light. So I wanted to put on a new head on this guy yesterday, and this little piece, the swirl ring, went plop, flying off when I went to go change the head. And I looked for it for ages, not been able to figure out where it was, till finally I realised it was in my junk pile. It had fallen into my pile of scrap steel, which meant you have to carefully disassemble everything in my pile of crap, because it's a small little plastic ring, brittle, that I didn't know the whereabouts of. And going on Amazon.com, they told me you could get me another one in a week. There you go, that's as clean as it's ever been. So this coil, this is the ammo for the welder. As you weld, it spits this stuff out and the current melts it and all that jive. But for doing this guy, it's going to be stainless. I need stainless ammo. There we go. So you disengage the motor. And you draw back this guy. Very careful. Whoop. Oh, you try to avoid that. It slipped through my fingers. Stupid numb fingers. The holes on the side. Take the coil off. Oh, the spoon. Whoa. Yeah. Now generally, for welding stainless steel, you just use TIG welding. It's much cleaner. But because I'm, building up various shapes, like I have to make some parts of the base plate thicker, and I have to do a lot of heavy build with the face, I'm going to use stainless MIG wire, which I've done before many times. The only thing I don't like is the stainless wire is a bit stiffer, and because it's stiffer, it's more prone to snagging and binding up in the feed. This thing for this mechanism for feeding it. Even though this guy is copper coated, it can still rust. It's important to keep this guy somewhere safe when you're not using it. The other disastrous thing that can happen is that it gets spatter on it from other welding. You don't look like you're paying attention, you look like you're dicking around. No, don't take that, that's not for your kind. These are better. One of the important, this is stainless, Matthew. Did I explain this? The guy wanted it stainless. And so, to keep, the only important thing with stainless to keep track of is the abrasives. Is when you're doing with stainless, you should make sure that the abrasives you're using have only been used on there's certain abrasives that I don't know the name of or which type they are, that you shouldn't use them on stainless at all. But in my experience, these guys are fine as long as it's a new one out of the box and it hasn't been used on regular steel yet, because sometimes transfer can happen where if you use a sanding disc or a grinding disc that's been used on regular steel, if you go to use it on the stainless, it'll impregnate the surface, and then, impregnate. Well, I don't know what other words. Penetrate. Permeate. Yeah, and then your stainless steel thing will have little flecks of rust on it, which you can then go back and clean off. But because of the nature of these guys, it's harder to do that than. It's harder to do that than just to make sure that they're, because you have to grind away material to clean off the surface. So it's easier to just start off with a brand new one, and then just afterwards I'll be putting these in a Ziploc baggie and maybe probably writing stainless on the Ziploc baggie and going, those are the ones for stainless, and then blah 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 blah. Anyway, the thing we're actually doing, the reason we're sanding off the back of this is these have to be brought down with the heat, and this has to be slightly curved so that this table represents the surface the actual blade is at, and we want the face to rest on the surface. Am I making sense?
Yeah.
Are we going?
Mm-hmm.
Okay, so I'm going to be building up a lot of weld here and stuff to get these so these are not two separate looking objects. But the first thing I have to do is bend these guys down closer to the surface of the disc. Or, not the disc, the 3D disc. Hemisphere. Sphere, you know what I mean. And then this guy I'm going to bend around too. And to do that I'm going to use heat. When you're heating stainless, the thing you want to watch out for is you don't get it stupid crazy hot. Because then you burn the chromium out. I don't know what stupid crazy hot is. I have never burned the chromium out of a piece of stainless. Okay, and so that's the, now it's close enough that I can fill in with weld, start making this look like one continuous creature as opposed to two separate plates. So that's all the welding done. It looks really, really ugly at the moment. But that heavy build has given me enough raw material that when I grind back, I'll be able to get the shapes that I want. I'll have to lever it up and get that from the back. Can't get it properly. Oh well. Cutting the bit off the back so I could get at the eyes properly, I blasted through the forehead. I guess this was the thinnest point. You know, I was like, I couldn't get the small disc with the small cutting disc back in there, so I had to use the plasma cutter, and most of it was fine, even though it was a bit delicate, but just two tiny little points here, like it blasted through. But anyway, now I can stick the die grinder in the eye, in the ocular cavity. Oh, it's gotten too dark outside to see. So that's it, more or less done. I mean, a little bit more. The main thing that I wasn't able to do is I want to hit it with the steel wire brush in the grinder, but I'm still waiting on a stainless steel one of those. That's a funnier, rare item, so I had to order it from someplace weird. So the pommel on this guy does this odd, off center pommel that I'm going to. I didn't have a one big lump big enough to do it, so I'm going to have to do it as a composite piece out of several different bits. So probably would have been easier to find a great big stainless lump and make the pommel out of that. But try as I might, I couldn't find anywhere that had stainless bar that was 2.7 inches diameter who was willing to sell me just like a short little nubby piece. I had to look around, but it's a weird, you know, it's a weird dimension to find. You know, even if I'd found like a stainless bar that was like 3 inches or whatever, I could have cut it down. But most places it was only one, like they went up to 1 inch or this, you know, heavy duty pipe stuff. But no great big stainless bars or chunks for me. So the handle gets wider towards the bottom. Now, if you're doing a wooden handle, that's easy enough to do. You just shape the wood that way. Wood's easy to work. If a blacksmith wants a piece of metal to taper, well, this piece would be thicker than this piece. Or they start off with a piece this thick and then taper this down. But for what I'm doing, I already have the pipe this thick, so I don't want to. I could squish this and that would make it flatter, but then it would make it wider, but it would also make it flatter. So instead I'm going to weld bits on the side, which is another option you have when you're a welder. That's the diameter brought down to what it needs to be. Now I'll start this outer taper. Can you guys see what's going on there? This is facing towards you, like this is the bottom of the thing. Although now I'm going to bring it in. It's weird too. It's not centered according to this guy. According to this guy, the taper is deeper and more rounded on this side than it is on this side. So from about this point up, it's just made out of weld. I need to get the steel wire brush. I wish they'd arrive. So now that I have the handle more or less built, I'm going to mark the spiral on the handle. Normally what I do for that, because I carve it in, like a lot of the video game ones where it's like a big steel looking thing with a spiral carved in, it's supposed to be emulating wood or whatever. But for my steel handles, what I do is, because it's not, or wood wrapped in leather I should say, because I don't have a big leather strap wrapped around a wooden handle, like get a piece of string or wire or whatever and copy what the faux leather wrap texture is doing, and then I just carve it directly into the steel to make it look like it's a wrap, but in fact it's just, hang on. Okay, so that's about right. And so I copy what the wire is doing. You know, I just go along it with a Sharpie, and then that gives me a guideline for what to carve in with the grinder. I'll refine it a bit more with the sander, but that's the basic idea. So with all the warping and the heat, you know, my amount of fine control over this is somewhat limited. But as it turns out, I did a thing where I you know, took a square, drew a line down to where the teeth run across directly on the blade, and then took a measure to see how close I got. And so that measures, just as you can see, around 65, 60. No, it's 65. But when you do the same thing here on this part, you know, this is the top of the blade. So I was like, oh, I wonder how close it is, and then if it's not close, I can do adjustments on that to fix it. But ta-da! Oh wait, that's out of focus. I don't know, can you see? So yes, it's also 65. I could claim I'm a master craftsman or something, but it was with all the warping and twisting and the heat, it's basically just a happy fluke. So what I was doing there, right, is I'm thickening up the edge of those horns, you know, the crossguard horns. I mean, that's what I think of them, the horns coming out at the side of the Soul Reaver, because I don't want to grind back just to the 1/4 inch. I want there to be some meat, you know. It should look bulkier than that. There's no hair left on the back of my fingers. It's a lot of work to bump it up, you know, just a little bit. Like, it's not... Is it a full quarter? It might be bumped up to a full extra 1/4 inch here. But, you know, it's like it gets shallower towards the tips and stuff. But, no, I think it's worth it. It takes away that look of... Maybe it's because I make stuff out of steel, but I can always kind of tell when something was, you know, started off as 1/4 inch and all of the detail is just carved into that 1/4 inch. You know, between all the grinding and stuff and the plasma cutting, this isn't an exact science, but oh man. Tiniest little gap. Tiniest little gap. Okay, I'm willing to call that equidistant. The teeth, same distance. I can measure this side. I can actually put the ruler in here, so this is fine. So round, just under 40. Ooh, that's a big difference. So the skull, hang on, the skull has to come way over. Oh yeah, I can see it at the back. So the skull comes way over. It's 38. 35. So it's 37, let's say. 37. We'll draw a thing at the side. We'll draw another thing at the side. Now let's measure these fangs again. It's way, way out. It's way, way out. What's happened? It's like the teeth of... Ah, I know. That is close to where I wanted it to be. Just spread this out. So just touching the fang. And now let's check this. So it has to come this way a little bit. Gap of about 1-2 mil. Gap of about 1-2 mil. Adjust it to make it more precise. Perfect. Now, nobody breathe. I'll put on. No, breathe if you want. I meant breathe. I'll put on the first tack. I don't normally do full runs. You don't see me do them that often because of the nature of what I'm welding. It's usually little short pieces here and there. But there you go. You can see, I think it was just the position of the torch, not the actual speed the feed was set to. That the wire was coming out just a little bit too slow, which went the amperage, the actual force that it melts, you know, the current, the power, was melting the wire a little bit too fast compared to the speed that the welder was spitting it out at. That's why it sounded a bit weird. See, like the trick with MIG welding is not actually doing a weld under ideal circumstances. Doing a weld under my ideal circumstances with MIG welding is easy. It's can you maintain a weld like a good bead when your welder starts acting weird. That's the actual skill involved with MIG welding. So the next thing I have to work out is the side has these kind of gill type things which look cool. Go away. Which way now? Go. This one goes here, and this one goes here, and this one goes here. Like this. Now, because the template I have stored is flat. Ah, yeah, that's it. The template I have stored is flat. I don't have a good record of what these shapes were supposed to be, because when you cut out the flat piece, it doesn't work because it you know it's relatively flat here, but then it rides up the hill this way. So it was you know, I had to dig around with little bits of paper. If I was smart, I'd record what these little bits of paper were doing somehow. I'd take a scan of them or something. But you know, if I was smart. I think vampire, my brain doesn't immediately jump to, oh yeah, you know, like a monster with gills. So that's the shape and position. Obviously it'll get cleaned up a lot, but it's a tricky thing because it's got like 3 or 4 different planes, angles going on, and switching back and forth between the plasma cutter, welder, grinders and the heat. It's kind of got 4 things I have to keep switching back between. You know, it seems like if you were a blacksmith or whatever, you'd have a completely different way of doing this. The other thing that I sometimes get asked about is, since I beat things into position and then tack weld them on, is there like a tension left in the steel? And there can be, but now what I'm going to do is come along and do these as full welds, you know, finish these 3 welds off, and the amount of heat involved doing that, if there is tension in that 1/8" plate, it'll be gone by the time I'm finished. So I cut the this thing a little bit big because my absolute nightmare would be not having enough material. So after getting it onto this edge, and the plate was overlapping the edge, I came in and trimmed. You can see where the gouge was a little bit away, and I was like, oh, and then got that little sliver out, which is on the floor somewhere here and red hot. And then after that, bash this down till it was on the same level as this artificial thick lip I've given this guy. And yeah, it's messier. Like a master craftsman might be able to make this plate the exact right size and the exact right shape before you even bring it over here to go click click. But yeah, 2 tacks. Tack where you want to start, tack where you want to end, and then brute force and ignorance to get the rest of it where you need it to be. Hurrah! These finally arrived. Come on. Yeah. So these are a bit more wee than the ones that you, the carbon steel ones. One of the grinders I have, you can adjust the speed, so I'm gonna set it to low. You know, I got a bunch of worries. These ones are smaller than the usual ones I get, and they're stainless steel, so they have to be a little bit softer than the carbon steel ones. So like that's why I bought 3 of these guys, because I'm worried about wearing all the bristles out before I'm actually finished doing the thing. So hopefully if I set the speed to low, and yeah, let's see how it does. So yeah, I can set the speed on this grinder, so it's set to the lowest speed, and it seems to be working fine. Like I was able to do this entire thing without, I mean, it's probably lost some bristles, but it's not noticeable on the, so at full power I was worried that the bristles would go flying everywhere. There you go. I have to do all of this business again on the reverse side. So now here I am trying to line up the 2 sides. Oh, this is hard to do one-handed. Let's see. Still looks like it has to go higher. From this angle now it looks like it needs to go lower. Or maybe it's in the right place. It's hard to tell. So that's the gills, etc., etc. put onto the other side. Oh, I didn't film a lot of that process because it was the exact same process as this side. Whoop. It's one of the most 3D of the swords I do. Bleh. Vampire. Oh. Don't look at this.
Okay.
No, I probably, if it did anything, it raised up at the back. Let's look. Oh, it has to come way up.
You wanted it up further.
No, see this? I mean, you can't see that from here.
No.
But see this? That's the actual true center. So
So
it has
you
to
wanted
be.
it.
This is where it has to go.
I was lining it up with that line that you told me.
Yeah, it has to be lined up with all of them.
But yeah, okay. So you want it actually higher than that line that you told me.
Okay, so this is where it's supposed to be.
Okay, fine.
Okay, now based on that, line it up. Now it's going into the center of the ball. Do you remember I said about the center of the ball?
Yeah, but you also said to line it up with that line.
Okay, so now does it go up or down? At the back? Up or down at the back? At the back, where my hand is. Up or down
Maybe
at the
up
back?
a tiny bit.
Yeah?
Oh yeah, sure, why not? Yeah.
What's your eyes?
And close them.
Okay, see now I can make fine adjustments, right? But
Yeah.
if I had attacked completely in the wrong spot, then I can't make the fine adjustments. Okay, thank you.
Sure.
These crazy swords with all the organic shapes. It's so hard to actually level up things properly, make sure things are in the true center. It's been years and years since I've trusted my eyes. Try to do everything by measurement. That's 340 to the edge of the dot. It's 340 to the edge of the dot. And it's so close. The other thing to watch out for is it's out by half a millimeter, and then you try to adjust it, and then this snaps off, and you're back to square one. So beyond just going straight in, ka-chunk, the handle has this kind of collar thing that this is a sphere, you know, translating from a flat surface. I got this spare sphere, that hemisphere that I was trying to measure it on. It comes 25 mil down. Like if you're looking straight, it comes 25 mil down, which is fairly shallow from this perspective, but then extends quite a ways this way if you're going this other way. And then so that does this widow's peak thing on top of the skull. So that's that cap collar thing on, and that's, I have to polish things up. Obviously, they there's a lot of grinder marks from the sandpaper. They look pretty severe under the artificial light, but they buff out pretty, easy with the steel wire. This is where the sword, the actual blade, will get welded on, this line. So I need a clear shot to it. Slightly annoyed. I'll weld this guy back on afterwards. Marking out the fuller. This works because this guy has got these two things on the back. So I'm going to cut the fuller in with a regular grinding disc, not one of my usual thin ones. So the fuller, I mean, it's not very wide. It's only, maybe 4 mil wide, which is, the regular cutting disc is only 1 millimeter. But I hate doing this part. I have to travel 4 or 5 feet with the grinder running and not mess up the line. Like if I go off the line, there's really no way to fix it. I'll just have to make it presentable. So here we go. No, I'll clean that up, but you can see how if I had started to come off the line, or if the thing had danced out of the groove on me and skittered across the surface, it could have done quite a bit of damage. The pencil grinder is air powered. My compressor is not, the most powerful compressor ever, so after a while I have to stop for it to pump up again.
There it goes.
I don't like sharpening the blades indoors, but so little light these days. I'm always worried I'm going to set something on fire.
This one winds up looking a lot more swordy than some of the ones I make, you know? Shiny. Doing slight adjustments to it. This is only stainless steel, so it's not too hard to adjust. Etc, etc. With these hard to reach areas, I like to take a strip of sandpaper and just a piece of a stick, and then this is as low tech as I get. I'll go in with some Scotch-Brite too, but the sandpaper takes care of the initial, there's marks from die grinding this. I welded it on the back, but this in here was a weld too. I just want to smooth that out, There's something there I don't like the look of, so I might take care of that. Is that another one there? There's something there too. Not too bad. 2 spots out of this entire 3 welds. So that's what the blade looks like after all the cleanup. It was a lot of cleanup. This is obviously the back side of it, but this, you can actually see the blade to hemisphere transition better on this side. It's harder to see on this side. Like the majority, the weld, this is kind of only cosmetic. The actual business weld goes straight across. Business weld. That's a funny expression I just invented. So now it's time for a little experiment. This I got these rods for doing for brazing over the handle of the Reaver.
The silicon bronze actually gives you a more coppery colour, a brown. So I got a. The trick is now, my memory is that oh, it's stainless. You have to use the silicon bronze. But that was a long time ago, so I'm just going to do a little quick thing here to see does it actually stick to the brass properly. Or does the silicon bronze stick to the stainless properly? So yeah, that was a short experiment, but you can see it worked. The regular brass rods, where are they gone? They're over there. They don't stick to the stainless steel. Or at least that's my vague memory of all of this. So yeah, you can see it's kind of a browny colour. I don't really have another thing around for comparison, but it's more copper colours than the yellow. Oh, so el disastro. The brazing didn't work at all. I just couldn't get the copper silicone stuff, the silicon bronze stuff to flow. Like normally when I'm doing this, you heat it up and it flows, but it just refused point blank. I tried to look up videos online to see was I doing something wrong. I couldn't find a video like this thing I do with covering a surface in braze and then polishing it back is a very unusual application. Other than me, there's only a tiny handful of people who do this. So there wasn't much for me to look to see what the hell I was doing wrong. So I spent the last day cleaning it up again to get it back to the way it was before I started. I didn't film any of that because that was a bummer and boring and it sucked. So now that I have it back to square one, I'm going to try something else. A lot of you have mentioned this with the brass brush technique, where you heat up the steel and then rub the brass with a brass brush and the brass transfers. The reason I don't normally like doing this is the braze is hundreds of times thicker and hundreds of times more durable. This technique, while much smoother, leaves a very thin coating, and I've discussed it with the customer, so I'll get away with it for this, the handle, because the handle itself isn't a high impact area. I wouldn't be happy doing this if it was like the blade or up near the head or someplace that would get bashed. Because this thing, where you heat up the metal and apply the brass this way, sandpaper can take that off if you're not careful. So here we go. This will take a while. I haven't done this in ages. It's important to, it's not brazing, so you don't need a whole lot of heat to get it going. I'm being extra careful with this because I don't want to overdo it. I don't know how see-through this brass coating is. Like if I heated a spot up till it was blue and then brassed over that spot, would you see the blue through the brass? It's a shockingly thin layer, Supposedly you can do this with just a regular blowtorch. You don't need the oxyacetylene. I mean, this seems slow, but it is faster than the brazing. It seems slow for the subtleness of the effect. If I had a rotary tool that had a brass brush, but when I was looking for one, I was basically confined to this island. I'm sure I could have ordered something
And I couldn't find any spinny brass brush for a drill or whatever in any of the places on island. All the places on island, and the internet for that matter, wasn't super clear or whether you were buying a brass brush or a brass plated steel brush. So if you're trying this yourself, be careful about that, because the brass plated steel brushes won't do this. Needs to be a real brass brush. So that worked pretty good. I wasn't sure how the brass was going to take to the stainless steel, but as you can see, I mean, it's yellow. So other than some minor cleanup, that's her done. That's a long sword. All that's left now to do is a formal test. Bleh.